Good morning, JT. How are you doing? I'm gonna get my phone set up. I forgot about my phone today. Yeah, I'm doing all right. All right. It is snowing. Which means I probably have stuff out in the yard that I forgot to pick up. Uh-oh. Oh well. I'll find it in the spring. Yes, it is snowing. Hard water is falling from the sky. I don't mean that it's got like calcium and other minerals in it. I mean that it's slowly descending from the sky in a non-liquid form. So we got that there. Okay, I wanted to come over here. Hold on. Guess we need to do this. Go back. Oh, you live in Missouri. Where's that? Wait. MO is Missouri. You live in Michigan. Yeah, okay. Oh, you got the water right there. Miami. No snow in Miami right now. Good guess, good guess. Unless, of course, it's like Miami, Montana or something. What is that place in Montana? There's a Sydney, Montana, isn't there? And whenever I think, Sydney, Australia, I always think Australia before Montana. So when somebody says, "Oh, I'm from Sydney," I'm like, "You don't have an accent." Like, yeah, I know. It's not a place in Montana that has a lot of accent. Like, oh, Montana. Yeah. I was. Oh yeah, I need my decoder ring. Find that. Oh, it's invalid. Oh, that was the wrong one. There we go. You only know Montana has the Rocky Mountains. A lot of states have the Rocky Mountains. All right, I wanted to go look at DynamoDB. That, and as that's loading, I'm going to fetch the URL off my phone. You love city name collisions. Yeah, they can make it challenging though. I was in a cafe here, and the waiter, we started chatting, just chit chat. It turns out they're from Australia, but they've been in the States for so long they have no accent, and I would never have guessed that they were from Australia. You were looking at your company's data in Italy, and the tool showed Naples data in Florida. Oh, that's funny. Morning, JB Brett. Okay, so we have that. Found the document here that I wanted to go through. So this bit here, I wanted to see what, I guess, the experts do for this. And I say experts kind of loosely. I have no idea if they're actually experts. Not because they're experts or not, just I don't know if they are. Okay, so going through that in a bit. Close that. All right, so in here we can create a table. I want to see what options we have. Create table, add, query items, monitor, manage tables. Okay. Sure, let's create a table. Table name, delete me. Right, partition key. Oh, I see. Let's say this is, let's do an e-commerce store. Australian accent seems like a hard one to drop. Guess it could be. I imagine it's harder to drop accents if you grew up in a place that didn't have the same phonograms. DynamoDB is a schema-less database that only requires a table name and a primary key. The table's primary key is made up of one or two attributes that uniquely identify items. One or two. You can add a sort key. Ah, I see. Let's just go through. Products. Product ID. Sure, it could be a string. I guess we could make that a binary or a number or something. Yeah, we could use UUIDs to make that a binary. I wonder if there are performance differences between these. Well, the primary ID is made up of a partition key and an optional sort key. Partition key is used to partition data across hosts for scalability and availability. Okay. Choose an attribute which has a wide range of values and is likely to have even distribution across patterns. So if we did have something like a UUID, that would work. Oh, you haven't touched the Dynamo service. Yeah, for me, I guess there's two things that really stood out to me. It was one of the few options I had for my criteria of not running VPS. And then also stuff like this. Let's go up to the top here. Seeing how other people use it. So. All right. Sort key. I have no idea what I would want for a sort key here. So what does it say for the sort key? The sort key allows for searching within a partition. Oh, I see. For example, an orders table with a primary attribute, customer ID, and sort order timestamp. It'll allow for queries for all orders to be by a specific customer in a given date range. Interesting. So here, the sort key, I wonder what we would actually sort them by. This price could be interesting. Oh, interesting. Even though it was one of the largest services covered on the certification you did for work. All right, I'm just gonna give it something. Let's pick an animal name. How about moose? All right, I have no idea what this is. What would be a good partition key or sort key for this? Maybe we should read the other document, but I want to see what the options are as we go through and just create this. Just to kind of familiarize myself with the subject, and then we'll go in and understand what they all do and mean. Table settings. The default settings provide the fastest way to get started with your table. You can modify these default settings now or after your table has been created. No secondary indexes. I think it's very likely we would use secondary indexes. Well, maybe not secondary, but global indexes. I do not have the required role to enable auto scaling by default. I am like super user on this account. For DynamoDB autoscaling, IAM users require additional privileges. I wonder why. I guess for cost reasons, maybe? Alright, well, that's interesting to know that. And if we don't do the thing, secondary indexes, so we can do the same thing. Projected attributes, keys only and includes. Create as a local secondary index. I think this is because you have global indexes and other. Typically there are service rules that are different from typical rules. They allow the service to assume into it, then do more actions. Huh. Often the console will auto-provision the role, or if you check for certain options. Oh, if you check certain options. Interesting. Okay. So the index name. Interesting. Okay, so it's not going to be like, this is a named index. I see. I don't think I want to do that. Select on demand if you want to pay only for the read and write you perform. No capacity planning required. Select provisioned to save on throughput costs if you can reliably estimate your application's throughput requirements. Okay, yeah, on demand is fine for this. Provisioned capacity, estimated cost. Oh, interesting. I have no idea. What is a read capacity unit? Capacity calculator. Whoa, whoa, whoa. I didn't mean to scroll the page. I just wanted to open that in a new tab. Oh. Auto scaling is enabled on this table. Oh, I see. So this is different than what I remember reading about the pricing. I remember reading about read capacity and write capacity. The estimated cost, I'm guessing it's going to be horribly low. Hmm. Sure, create one, that's fine. Encryption at rest. All right, go ahead and create it. See what happens. Stream enabled, no, it's fine. I thought we lowered that to 1. All right, what do we have in here? We can scan, we can query. Product ID, we don't have anything in here. Let's create something. Create item. Product ID. This is a product ID. That's interesting. It's an interesting sort of setup there. Moose. I don't know. It is an animal. All right. Now it looks like there we can insert and remove things. Let's say we inserted a map. Is what do we call this? Foobar and sure, a string. Some key, some value. Save. I see. Product, animal. Well, that's interesting all on its own. That you can have associated items here with the primary and sort key. Primary key and sort key. Let's see if we added another one. Type. Let's see, so we can have a list in here, we can have a map in here. So we might be able to have things like, I guess, products. I guess an order would make sense, like if you're thinking e-commerce, right? And somebody had a shopping cart, they checked out, then you would have a record and kind of a list, right? Or is it a map with a list inside of it? Can we add a list in here? Insert. Oh, we can add a list. And okay, let's give this a name. Oh, nice, you can have I guess this might be better as like product ID and quantity or price. So we'd probably want how many units there were, etc. don't think it would. Okay, I'm just playing around, but it's interesting that you can have complicated data structures like that. Does that map to our risotto? RUS risotto? There we go. Structs. Okay, some of these are for the configuration. List tables, yeah. I want to see. Okay, maybe I should have searched for map. Key schema element. Do they have like value, tag, attribute value? Represents the data for an attribute. Each attribute value is described as a name value pair. The name is the data type, and the value is the data itself. When you create a table or secondary index, you must specify the names and data types of each primary key attribute. Scalar types, strings, binary, sure, and document types. Document types are list and map. They can be nested within each other to represent complex data structures up to 32 levels deep. Huh. There's no limit on the number of values in a list or map, as long as the item containing the value fits within the DynamoDB item size limit of 400 kilobytes. That seems big. Also, if you fetch something like that, what is that? That's 100 reads? Because a read is 4 kilobytes in size. So not only do you have to kind of manage, so if you're thinking about this in managing costs, you probably want to be a little bit more selective about dumping things into something this size. Unless, of course, you've already chewed up your keys and sort keys. Because using the keys and the sort keys would allow you to be more specific about the data that you want. All right, list. Oh. All right. An attribute value can be empty string or binary value if the attribute is not used for a table or index key. Cannot be an empty set. Empty lists and maps are allowed. Okay. A list type attribute can be stored. Okay. A list type attribute can store an ordered collection of values. Okay, so they're ordered, lists are enclosed in square brackets, yada yada. Now sets, do they talk about sets here? Not really. Similar to a JSON array. There are no restrictions on the data types that can be stored in a list element. Oh, interesting. And the elements in a list element do not have to be of the same type. Yeah, that's different. So you could represent tuples in here or pairs of things. Let's see, an order. You could have like triplets, right? ID, price, quantity. All right, maps, name value pairs, closing curly braces. Go figure. Similar to a JSON object, there's no restriction on the data types that can be stored in a map element, and the element and the map do not have to be the same type. Okay. Ideal for storing JSON documents in DynamoDB. The following example shows a map that contains a string, a number, and a nested list that contains another map. Sets. All elements must be the same type. No limit, as long as they're within the 400 kilobytes. Okay. Well, interesting. Seriously? One letter field names. That makes me cry a little.
First time met you, I hope you stay in town. Pretty hair, pretty eyes, wish you were by my side. You are the best, any girl
I see.
ever wanna be.
A Boolean, binary set, binary. Oh. Is it really that hard to write these things out? All right. What other values do they have in here? Condition represents the selection criteria for a query or scan. From what I've read so far, scans are expensive, queries are less expensive. So if you needed to find a set of things, you would want to do it with a query, not a scan. A condition do. Expected attribute value. Delete item, put item. Oh, I see. This is like
My love for you will never fade, baby, I will hold true. Two worlds apart, how can I get to know you, babe? Why is this space so far? One tone, two hearts, though yours seems many miles apart.
This is like doing a compare and swap or kind of operations where you want to make sure that the value hasn't changed since you read it. There. What else do we have? Oh, here's another value. Revision throughput. Sure. Tag. Makes sense. And we did kind of gloss over tags. You can add up to 50 tags in a single DynamoDB table. AWS assigned tag names and values are automatically assigned with the AWS prefix. Okay, AWS ones don't count towards your limit. Yours are user colon. You cannot backdate the application of a tag. Any other values? All right, no. We were over here. Okay, so then we have this. Let's do a query. Scan, query. Sure, product. Product ID is... I see, and this is the partition key. How do I run this? Or is it doing it already? Go. Do I have to fill this in? Ah, you just hit enter in there. It's supposed to do it. How do I go back to not having this? Refresh? Oh, this is a product ID, product space ID. So query, this is a product ID. Okay, so we still have that there. Then if we had more than one, we could get a range or something. So if this was instead product, it would be a horrible name for it, but then we could sort through them based on something else. Data lake. Morning museum. Anyway, what else do we have in here? Now, I thought that you could also filter on the body of, let's say, the data. Global tables. Capacity. What are our metrics? Scan latency. Oh, interesting. So what are the latencies we're receiving? Read capacity. So it must be this one here. No, that's the wrong one. Ah, latency. So did we do, I thought we did a get, didn't we? Query. Okay, I do not see what we were just looking at in here. Does this query not matter here? Is an animal. What if we do this a couple times? Enter, 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 enter. Metrics, come on. I want to see latency numbers. Oh, here we go. Scan latency. I don't think we're doing a scan. We turn off dark reader. Maybe it's there and we just can't see it. Oh. No? Well, there we go. Got a bunch in there. The max 15 milliseconds? Okay. Minimum 3 to 4. That's not too bad. Oh, some of them have a dark mode? I wonder where you would set that up. Preferences? This looks like it's specific to DynamoDB. Now what is DAX? Oh, that's the accelerator. It's basically the mem cache in front of this. Oh, usually a slider on the top right. Gotcha. But it doesn't look like we were missing anything, so I'm going to turn that back on. Okay, so that's interesting. And the global secondary indexes allow you to query efficiently over any field attribute in your DynamoDB table. All right. So I wanted to go through this. It's a bit of a page. Almost. Let's see if I can do the command right this time. There we go. For the first 45 minutes of the reInvent session, I nodded my head. I was like, yep, that's how I think about DynamoDB. Then Rick morphed into some kind of NoSQL wizard, and from outer space, my mind exploded. Oh, they need a bunch of custom colors for each separate plotted line that works in dark mode. Yeah. All right. Well, my wife just brought donuts, so I'm going to take a little break. Hold on a sec. I did. So earlier, I did mention it was snowing. Hello, y'all. The powdered sugar on the donuts actually reminds me of the snow that's falling outside. They're like twists, pumpkin, and whole wheat. Really good. They're healthy donuts. All right. Donut time's over. So here they say Rick cracked the lid on a can of worms. Many of us who design DynamoDB tables try to avoid the fact that DynamoDB is not just a key value store for simple item lookups. If you design it properly, I think this is probably the most important piece here. If you design it properly, a single DynamoDB table can handle the access patterns of a legitimate full table relational database without breaking a sweat. A legitimate multi-table relational database. So a single DynamoDB table can handle the access patterns of a multi-table relational database. If you design it properly. Rick's video and the related document. Oh, let's open that up. I didn't see that. Example of modeling relational data in DynamoDB. Oh, interesting. Okay. I don't know. I might take a side trip. See what that says. Densely packed with advice on how to construct a DynamoDB table that will match your relational DB's query performance at arbitrary horizontal scale. Heavy stuff. Okay. All right, so first let's take a look at this. How to model a relational database in Amazon DynamoDB. DynamoDB table. I think I will start this probably. Sure, other bookmarks, don't care. DynamoDB table design corresponds to the relational order entry schema that is shown in relational modeling. Okay. It follows the adjacency list design pattern, which I'm not familiar with, which is a common way to represent relational data structures in DynamoDB. All right. It's funny how sometimes you get into like a new system of things and you see new terms and you're like, I don't know what that is. And then you look at it a little further and you're like, oh, I've been doing that for years. But you just didn't know what the name was. Guess we'll figure out what that means. Okay, let's take a peek at relational modeling. Traditional relational database management systems platforms, blah, blah, blah. Oh, goodness. Hard time reading today. Traditional relational database management systems, RDBMSs, store data in a normalized relational structure. Good old MySQL Workbench. Following example is an example of a generic order entry application with supporting HR schema backing the operational and business support systems of a theoretical manufacturer. So you have products, you have inventory. Inventory is in a warehouse. Okay, so the location. Products can be an order item. So orders, wow. Lots of little bits and bobs in there. Hey, Lilybite. We are looking at DynamoDB, or at least how to use DynamoDB beyond a simple key value store. Because apparently you can do crazy things like this, but with DynamoDB. You just have to know how. One-time queries of this kind are kind provide a flexible API for accessing data, but they require a significant amount of processing. You must often query the data from multiple locations. The result must be assembled for presentation. Okay. A relational database system does not scale well for the following reasons. It normalizes data and stores it on multiple tables that require multiple queries to write to disk. Okay. Generally incurs the performance costs of an ACID-compliant transaction system. Okay. Uses expensive joins to reassemble required views of query results. DynamoDB scales well for these reasons. Schema flexibility lets DynamoDB store complex hierarchical data within a single item. That's interesting. I wonder what they're going to take out of this big graph and store in a single item. Like what parts of those get stuffed in a single item? Composite key design lets it store related items close together on the same table. Yeah, I think Amazon, DynamoDB, and MongoDB make the same trade-offs with the cap theorem. I'd have to double check, but I think because of that, they have the same sort of capabilities. Oh, and there is a MongoDB interface for DynamoDB. All right, first steps. NoSQL design requires a different mindset than our DBMS design. You can create a normalized data model without thinking about access patterns. You can then extend it later when a new question and query requirements arise. By contrast, in Amazon DynamoDB, you shouldn't start designing your schema until you know the questions that you need to answer. Understanding the business problems and the application use cases upfront is absolutely essential. So yeah, that's very different. It's kind of like how to know what who's going to own what data in your Rust program. You got to think a little bit further ahead. You have to think, will the borrow checker hate this? Will I anger Clippy? It's either that, Xenocron. So to quote Xenocron here, it seems like whoever wrote that note has never done RDBMS design. I was thinking the same thing, actually. And I think that actually comes from somebody who's... So, when they say this here, you can create a model, normalized data model without thinking about access patterns. I think they're talking about just a normalized data structure. Like, you can create a normalized data model without thinking about access patterns, which is true. You can create a normalized data pattern or data model and not even be concerned about access patterns. Because normalizing data just is about, what is it about? It's about reducing redundancies in the data system. To start designing a DynamoDB table that will scale efficiently, you must take several steps. First, to identify the access patterns that are required by the operations and business support systems, OSS and BSS. Okay. I agree. And I think that comes with experience, right? That's like doing Rust and thinking ahead to, will the borrow checker hate all of this? Because there are 7 levels of normalization, and you don't often want to do all of them because of access patterns. Um, for new applications, review user stories about activities and objectives. Document the various use cases you identify and analyze the access patterns that they require. Interesting, because if let's say we're writing a forum, and a forum, I don't know, it's just easier to think about than e-commerce store. E-commerce has many more moving parts. So if we think about forum, where you have kind of topical groups, right? You might have forums about Rust, or forums about MySQL, or forums about DynamoDB. And then inside of there, you have a thread, right? You have a post with responses. So having things that are listed in order makes sense. Like, how am I going to show the user the data for this URL? You'd probably need enough information in the URL to determine where the user was or is wanting to see. Right? What speaking is hard. And I could see doing this where you partition it up so that your primary key and your other keys are kind of across hosts, so you can just grab a series of posts for a certain page and go from there. So you might want your sort key to be the order, or maybe you just have the whole thing as, maybe you have all the posts in one key as a list. That's possible too. Or perhaps you partition it by size, right? 10 posts per item. That might work. But then how do you do searching? What if you wanted to list all the posts by a certain user? For existing applications, analyze query logs to find out how people are currently using the system and what the key access patterns are. Key access patterns. Not all of them, but just the key ones. After completing this process, you should end up with a list that might look something like the following. Look up employee details by employee ID. Query employee details by employee name. Find an employee's phone number. Wouldn't that just be looking up wouldn't 3 be the same as number 1? Show all open orders within a given range across all customers. Okay, that's a good one. All right. In a real application, your list might be much longer, but this collection represents the range of query pattern complexity that you might find in a production environment. Reinventing entity modeling. Yeah. The most that I've really gotten into NoSQL stuff, Cassandra, forever ago. I remember fixing a bug in Cassandra. It had to do with a memory leak for binary bits. Because they have these binary blobs that they weren't managing well. Little known fact, you can actually get memory in Java through the normal Java APIs and leak it. I don't even remember what the name of the API is. Java binary blob. Because I know they have some sort of binary API. Get binary stream? No, that's SQL blob. That's not it. Is it blob? Because there was a bug, oh goodness, forever ago. How long ago was it? It's funny, I have to. Let me check my profile. Oh. One moment. I want to see, when did I work at this one place? Oh, a decade ago. How about that? But yeah, there's a way that you can actually get binary data, and you have to manage it better, differently than you would normal Java objects. And it's very powerful in that it lets you, gives you, pointers, basically. Okay. A common approach to DynamoDB schema design is to identify application layer entities and use denormalization and composite key aggregation to reduce query complexity. I do like relational databases. I would use Postgres here if I could. So you'd rather use a NoSQL database as a relational with virtual foreign keys rather than other solutions. I see. That makes sense. It seems like you have to be certain of how the product will work for a very long time doing this. Okay, now I want to reread this here. Identify application layer entities. Okay, it's like product, etc. And use denormalization. Denormalization is the duplication of data. Okay, and use denormalization and composite key aggregation to reduce query complexity. I want to know a little bit more about this composite key complexity. So I want to know what that means to DynamoDB. Oh, next paragraph. In DynamoDB, this means using composite sort keys, overloaded global secondary indexes, interesting, partitioned tables/indexes, and other design patterns. You can use these elements to structure the data so that an application can retrieve whatever it needs for a given access pattern using a single query on a table or index. I see. So you're looking to ask a question get total product inventory. And it can do that just straight off. It's basically, what are all of your queries and how do you design these keys, indexes, etc., sort keys, so that you can answer each one of them. Primary pattern that you can use to model the normalized schema shows in. All right, the primary pattern that you can use to model the normalized schema shown in relational modeling is the adjacency list pattern. Okay. Other patterns used in this design can include global secondary index, right sharding, secondary index overloading, composite keys, and materialized aggregations. I'm going to open that one in another tab. Example of modeling relational data in DynamoDB. Goody goody. Okay. This example describes how to model relational data in Amazon DynamoDB. A DynamoDB table design corresponds to the relational order entry schema that is shown in relational modeling. It follows the adjacency list design pattern, which is a common way to represent relational data structures in DynamoDB. Oh, we already saw this. Ah, you know what? We actually got to this piece here. Clicked on that link. Yeah, see, look. We made our way back to this link. Okay, so we're going to keep going. So from here, follows the adjacency list design pattern. So let's figure out what that is. Best practices for managing many-to-many relationships. Okay. More generally, they provide a way to represent graph data, nodes and edges in DynamoDB. Interesting. When different entities of an application have a many-to-many relationship between them, the relationship can be modeled as an adjacency list. Okay. In this pattern, all top-level entities, synonymous to nodes in the graph model, are represented using the partition key. Any relationships with other entities, edges in the graph, are represented as an item within the partition by setting the value of the sort key to the target entity ID. So the sort key, hold on, so the sort key becomes the other node ID. Okay. The advantage of this pattern include minimal data duplication and simplified query patterns. Real world example. Goody goody. Okay. I've been saying that a lot today. I don't know why. Goody goody. I don't think, do I normally say that? I don't think I normally say that. A real world example where this pattern has been useful is an invoicing system, where invoices contain multiple bills. One bill can belong to multiple invoices. Ooh, interesting, okay. The partition key in this example is either an invoice ID or a bill ID. Bill ID partitions have all attribute-specific bills. Invoice ID partitions have an item storing invoice-specific attributes. And for item, and an item for each bill ID that rolls up to an invoice. So here they have the data attributes. Here they have date. Yeah, the partition key is the sharding key. That's what we saw over, where was it? In the actual DynamoDB here, where we were creating, I forget what we were creating. It wasn't an index. Was it an item? No. No, it was when we were creating the table. Here, the table name, here. Optional sort key. The partition key is used to partition data across hosts for scalability and availability. So yeah, the primary key distributes, or is the sharding key. Oh, interesting. So all they're saying is to use a node ID as a sharding key, so that reading a node's edges does not require aggregating data from multiple shards. I don't know if that's, is that true? Because if a partition key, here, I get that these are strings, but they might hash it. I wonder how they use these partition keys to determine the host. Because you're right, depending on how they use that partition key, it could end up on the same host. And then here, the second column for the primary key, they've got in this, they have the table, they have the primary key. Primary key has, say, invoice-92551 and bill-4224663. And then the sort key actually points to the other element. Interesting that they have multiple sort keys for the first invoice. Can we do that? I'm gonna go back here. Go back. Here's our table. Here's our item. This is a product item. Now let's say we wanted to add a second sort item. How do we do that? Can I mark foobar as something? Can I say, oh, you are a such and such? I don't see it. What other, oh, here's actions at the top. Am I going through that? How do you set up these additional sort keys? Using this preceding schema, you can see that all bills for an invoice can be queried using the primary key on the table. Yes. To look up all invoices that contain a part of a bill, create a global secondary index on the table's sort key. Oh. MC Lars. All right. Overview. Where is this? Indexes. Global secondary indexes allow you to query efficiently over any field in your DynamoDB table. Okay. You can treat any table attribute as a key, even attributes not present in all items. fancy. Approximate creation time is 5 minutes. Wow. No, interesting. Notification will be sent to the SNS topic DynamoDB once the index is created. Okay. Global PK. Yeah, sure, we'll add a sort key. Index name, that's fine. Projected attributes, all of them? All right, we'll just hit save. I do not expect that to take very long. 5 minutes for one table with one entry. Seems like that would be asking a lot. But how does that end up giving us multiple sort keys on an invoice? I still don't see that. Oh, can you create multiple rows with the same invoice ID? Items, product ID. So let's say we create another one with this. That should be the same as the other one. And squirrel, moose and squirrel, save. Oh, that works. Oh, okay, that's interesting. Wow. You can have multiple primary keys, or I keep thinking primary keys. This is a partition key. So if we do a query, this is a product ID, get all of them. This is a product, enter, get none of them. Okay. Well, that's cool. Okay. Okay, so the partition keys can be duplicated, which is how I imagine they did this. Now I'm wondering, does this mean that we can actually reduce these elements? So let's say you had a forum post, right? Does this mean that we can have the post ID in there 100 times and then have the sort keys and the data attributes be different? It looks like it does. So you can break it down quite a bit. Wow, that just flipped how I was thinking about it. And what if we had the same key and same partition key and sort key? Let's create another one. Moose and squirrel. Ah. Conditional request failed. Now it didn't really give us much, did it? It says, no, you can't do that. What if we make, or I'm gonna try it again, hit save. Still nothing. Okay, so it's probably not time related or because we have that global index going on. Now if we hit save, yeah, so partition key and the sort key looks like it has to be unique. All right, now if we do another product ID, we have a foobar baz and squirrel, save. Okay, that's fine. So it's a combination of the partition key and the sort key have to be unique. And what if we had a table? Okay, the Stone Cold Man. So the combination of sort plus range has to be unique. Got it. So if we have another table where we didn't have the sort key, does a primary key have to be unique? So let's say we have a table called no, or delete me, no sort key. We'll do shapes. All right, so we have this. It doesn't have a sort key. It's being created. Hey, Miguel America, how are you? I've got about 10 minutes because I got a meeting at 9. Shape, circle, square. Fine. Circle again. Okay, now because we don't have the sort key, yes. So that does make sense. It's a PK plus SK. So the partition key plus the sort key has to be unique. And when you don't have the sort key, well, that combination still has to be unique. So it's just like having a null sort key. Okay, so that answers that question. I don't like this graphic here, and that it makes me feel like for the invoice dash 92551, like there was one entry. But I don't think there could be because there are 3 sort keys. That's pretty interesting. So let's say you had forum posts. In this case, you could have like a post ID as the partition key, or maybe it's a combination of thread ID plus post ID, something like that. Or maybe it's just, no, just post ID. Then you would have multiple sort keys. You would have one. No. I guess it depends on how you wanted to organize this, because yeah, you could reverse it too. So you would probably have a partition key being the thread, and then the post for the sort key, and then also one having the post ID as the partition key, followed by the thread ID being a sort key. I mean, it's going to double up the number of rows that you have, but it's going to allow you to answer the questions that you need to answer. What are the posts in this thread? Then you could also toss in, like, who created this post? It's like that. Yeah, Miguel America, I am doing well, thank you. It's almost 60 degrees in here. I'm starting to get used to the cold now. It's going to take another couple weeks. It's like going out to the office is practicing Wim Hof. Use GSI to query the data. Okay, so the Stone Cold Man says, use GSI to query the data. Try to have some attributes on which you can create GSI. to query for what you want from it. That's better than duplicating it. I see. Which is over here when we were creating these indexes. Where did it go? Oh, this is the delete me one. Let's go into the products again. So here we have this element. I see. Yeah, that makes sense. Okay. Yeah, you heard that I might want to duplicate an item for querying purposes. So using these here, is now I have this index, right? Its attributes is everything. That seems like it would be expensive. But if we go into items, and let's say we had, let's say the product ID, and we wanted to add, let's say, string. What's there? Oh, it should have been a number 1.23, $1.25. Where'd it go? Oh, it's over there, product cost. So then if we wanted to query this, add filter. Did I call it product cost? Yeah, underscore cost. String is equal to 1.25. Enter. Oh, enter value for the product ID. Oh, that's interesting. So you have to have a product ID in your query.
Open eye, feel the waves cut through me, hypnotized by the sounds I'm breathing in. Hold tight, chemicals collide.
You've always been pretty, let's see, Miguel Murga says, I've always been pretty confused about the concept of serverlessness. Doesn't mean there isn't a server, right? That's correct. It means that there is a short-lived server. Let's see. And the Stone Cold Man says, you can't do that. That's why having a sort key, which can be like animals, and then you can create a GSI on Moose, product cost, and then query it. I see. Why use serverless then? Cheaper? It has the potential of being cheaper, right? If you have a very light usage. You don't have to manage it, as Anacron says. And then it also scales better. Well, it can scale. I don't know if I want to say better. It scales differently. So in this case, using the preceding schema, you can see that all bills for an invoice can be queried using the primary key on the table. To look up all invoices that contain a part of a bill, create a global secondary index on the sort key. I see, which is the bill ID. So their GSIPK, in this case, is bill ID, and their value is the bill. So if I wanted to get everything just for that invoice, will it also return the sort keys for me? So let's do another query. Let's say I don't have a filter, and I just want to search for that. Now does this also return the other sort keys? It doesn't look like it. Oh wait, it does. It does. But not the global. Oh, I see. The global sort keys are actually the column here. It's just an index into one of the, what do they call these, properties? So the GSI, so coming back here, the GSI PK here is just one of the attributes of this row. I see. So in this case, you have your sort key, your partition key. So your partition key in this case is either going to be invoice dash blah 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 or bill dash blah blah blah. And then on that row, the sort key is the invoice ID. So you can sort but why is the sort key the same as the partition key? I do that I don't get. Why? Because you have to specify the partition key directly. Unless I missed something over here. Because it doesn't look like I can specify just, let's say, the sort key. I have to enter the product key here, or the partition key. So the partition key has to be specified. I don't think that it has to be equal. It's not like I can compare these. Begins with blah blah blah. You cannot do that query of get me all items of this price. I see. Now, riddle me this: why is invoice ID invoice 92551 the partition key and the sort key? If you look at the, what is it, third column? First column says table in it. Then you have the partition key. The third column has the sort keys in it. All right, maybe they'll answer that question here in a minute. The projections for the global secondary index look like the following. Materialized graph pattern. Okay, now we've gone out of this pattern. Yeah, adjacency list design pattern. Yeah, this is just giving me more questions. You can create a GSI with product cost as hash key sort on moves. Oh, I see, where product cost is hash and moves contains squirrel. So, Stone Cold Man, do you know why they have the partition key and the sort key the same? Um, so in this example here, this image in the center of the page, it says, let's say for the bottom row, bill-4224687 has a bill ID of bill-4224687, which is the same as its partition key. Because if you have to specify the bill ID, then what's the point of having the bill ID as a sort key? I kind of wish they marked which one of the that column where it has multiple entries for, let's say, invoice dash 92551. There's an invoice ID, there's a bill ID, there's another bill ID, but I don't understand why the invoice ID is in there again. That's a GSI where the sort is switched with hash. So what can you do with the GSI? We've got query. Probably don't want to look at scan at the moment. Give us a little bit more room. GSI PK, partition key, not primary key. Stun server is basically the ability to have two clients connect to the same server, and then the server directs them to connect to the open ports on each other. Basically, it allows you to connect through what is it, NATs and stuff like that. Okay, I'm going to try to read this again. Using the preceding schema, you can see that all bills for an invoice can be queried using the primary key on the table. Oh, shoot. I think I'm late for a meeting. I gotta get going. All right, well, I've got to bail. So we'll see y'all. I gotta run. Bye.